Up-down metal folding explained. With folding machines that only bend upwards, the movements of the beams and the back gauge are simple and manageable. The back gauge fingers position the sheet on the bending line. The upper beam clamps the workpiece, and the rotation of the folding beam forms the metal part to the programmed angle. Then the upper beam opens, the back gauge is repositioned, and the next bend takes place. Machines that bend up and down are significantly more complex. Even at first glance, the lower beam has noticeably more free space for negative flanges. If, for example, a Z-bend is to be formed, the first bend is made downward and the second upward. During the process, the stops first position the blank and the upper beam clamps the material. Then the folding beam lowers and rotates around the protruding flange. On the way up, the beam is offset with the width of the tooling through a pendulum motion so that it is in the correct position at its uppermost point. The first bend moves downward. Then the folding beam makes a free move away from the material to once again be offset in the opposite direction once it reaches its lower home position. The back gauges move the blank forward. The folding beam positions against the sheet and completes the Z-bend. In the case of negative bending, the specified tool is positioned to the clamping point. Once at the bottom, the pendulum moves the beam to the other side of the tooling. The beam can even lift the negative flange over the lower beam, thus simplifying handling when closing hems. For subsequent positive bends, the rear tool edge is directed to the clamping point. Controlled pendulum movement when changing bending directions. Regardless of whether wide or narrow folding beam tools are used, the pendulum movement automatically adapts to the tool width. Although the sequence of motions appears complex, the machine user doesn't have to concern themselves with programming them. The Bendix